Hello, everyone. This week's topic is the different effects of lighting. We'll specifically be talking about color and the directional effects. We'll start out by discussing how exactly do we as humans see the world around us and kind of the anatomy of our eyes. Then we'll move on to discussing color and light. We'll talk about the different lamp color specifications and then move into the directional effects of lighting, including brightness and glare. So, how do we as humans see the world around us? We see with our eyes. All right. And here is a illustration of kind of a cutaway section through an eye. Light will enter from outside through the cornea here, and it will pass through a lens, right? The lens focuses the image of what we're looking at onto the retina, which is back here at the back of the eye. At that retina, there are rods and cones, and they convert the light energy, those wavelengths that we talked about in the last module, into a series of electrical impulses. Those electrical impulses go to our brain, all right, and the visual cortex of your brain interprets them as shapes, textures, and forms. The amazing thing, well, truthfully, the whole thing is pretty amazing. But one of the amazing things is that our eye can detect more than 5 million colors. Another amazing thing that our eyes do for us is they can focus on items close and far. All right. And this this feature is called accommodation. And accommodation is the instantaneous, really, change in the shape of the lens. Remember the lens in the last slide, which bends the light to form the clear image on the retina. If the accommodation is not precise, it can cause near or farsightedness, and we might need glasses. Another interesting property of our eyesight is that we can um, adapt to different light levels, and that process is called adaptation. And the size of the pupil in our eye is going to change, all right, to allow varying amounts of light in through the lens to hit the retina. And human eyes have an amazing range of adaptation. All right, we can see in a bright summer's day, and we can also see at a moonlit night. And they're about, what is that, 100,000 times different? um, and it turns out that a dim to bright transition is much faster. So someone walking from a dark area into a bright room, for example, the adaptation will happen very quickly. But if you were in a bright room and move out into a more dim or darker space, that transition can happen much more slowly. In some cases, an hour. I mean, a long time. All right, so this is something that we as designers need to take into account. I'm going to let you learn more about human vision and our eyes from some material that I've placed in your module for you. Thanks, everyone.